This is video on statics of coplanar non-concurrent forces. This is the third video in the series, and in this video we are going to discuss equilibrium equations, fundamental equations of equilibrium, then type of loads which you normally encountered in solving equilibrium problems, and type of supports. So again, you see, if you have the overall look at the study of statics, as you know, there are two parts, concurrent and non-concurrent, and each of these they are finding resultant and equilibrium, and in this video we are looking at equilibrium issues, fundamental equations and all that, and later on, of course, we are going to see the applications. Okay. So equilibrium of coplanar forces, if we talk about it, let me explain it like this. Let there be a coplanar non-concurrent system, okay, as shown in this figure. There are forces 400 Newton, 250 Newton, 375 Newton, then there is a moment, then there is another 728 Newton at the known locations, and is there inclination, magnitude, everything, let's say, is known. Now, from the video 2, you know how to find its resultant. Very simple. What you do is you find resultant. You think all are concurrent. Find resultant sigma fx I plus sigma fyj, and then find moment. The total moment of all these forces about origin you find, and then this resultant force and resultant moment gives us the resultant force system of this concurrent force system. Now, if we say that this system is in equilibrium, that is, if these forces and moments are acting on the body and body doesn't move or rotate, then what is guaranteed is that resultant R must be 0 and resultant moment must be 0. It means in scalar form, if you are told that system is equilibrium, is in equilibrium, then you are assured that sigma fx is 0, sigma fy is 0, and sigma m about origin is 0. You are assured of this. So therefore, these three, see, sigma fx 0, sigma fy 0, sigma m equal to 0, form equilibrium equations for coplanar non-concurrent force system. And by applying these three equations, you can literally solve any problem, as long as, of course, there are only three unknowns to be done, three unknowns to be evaluated. So we are going to do in next videos a lot of problems on equilibrium of coplanar force systems. But before that, what is required is some knowledge about the type of loads and studies, and that is here. You see, normally structure will be loaded by what is called uniformly distributed load. Now you see, this is 5 Newton per meter load distributed over 8 meter. Now how do you handle it? You handle it by replacing it with one vertical load shown in this by this red. What is the magnitude? 5 into 8. And where does it act? At the center of this set. So in a given problem, if you find the distributed load, you can simply replace it by the total load acting at the center of this rectangle. Similarly, you may have triangular load. You know how it is? That on one side there is let's say 5 Newton per meter, other side is 0, and load is increasing continuously. Now equivalent of this load is area of this triangle, 5 into 8, 40 by 2, that is 20, and this acts at the center of the triangle, that is 8 by 3 from the right end, that is the end where the load is maximum. So you can replace the triangular load by this sort of vertical load. Okay. Now suppose your trapezoidal load, say one side is 9 and other side is 4. Then you can convert this into a rectangle and triangle, and each of these you know what is equal. For example, this 5, see this side is 4, it's not written here, it's written here 4. So what you do is it consists of a rectangle of 4 by 10, so total load is 40, and a triangle of one side 4 and the base 10, so one side 5 and the base 10. So the total load is 50 by 225. So you can replace this trapezoidal load by these two loads, 40 acting at center of the rectangle and 25 acting at the center of this triangle, and these two together can replace this trapezoidal type of load. Now let's look at supports. You see, in structures there are all kinds of supports, like beam resting on the wall, beam going in another beam, or column resting on a foundation which is isolated, or column going in a foundation which is raft-like. So what they have done is all types of supports in the world they have categorized into 4 types. So one of the supports is called hinge supports, and the property of this support is this support can be replaced by certain forces, which I'll show you. But the total type of 4 supports are hinge support, there is internal hinge, there is fixed support, and there is roller support. Now each of these supports are associated with the reactions. For example, hinge support is associated with 2 reactions, one horizontal and one vertical. Roller support is associated with only one reaction, that is vertical. Fixed support is associated with 3 reactions, one horizontal, one vertical, and one moment reaction. And internal hinge is associated with one horizontal and one vertical on each side of this internal hinge. Now you see, this information you will find it very handy when you are actually doing applications of equilibrium of coplanar forces, which are beams, trusses, and so on. See, what happens is for every problem it's not possible to describe the way it is supported. So any support in the world can be fixed, identified as one of these 4. For example, just to give you an example, you know, the door flap of any door flap is attached to its frame by what is called hinge. Now, so anytime you are idealizing that support in a given problem, you are going to write like this hinge. And what is the property? See, the door can be moved in door can be rotated. See, door can be rotated, the door flap, it can be open and closed. But mind you, door cannot be taken moved in a horizontal direction or vertical direction. So that is the property of hinge. So that is the hinge support. Similarly, roller. Let's say I keep a chair on a floor. Now I can move it horizontally, but you see I can't press it down the floor. So it's as if, so that support will be given sort of by roller. Then fixed support is, let's say, a beam going into the wall. Now it cannot, that support gives or assures us that it cannot be moved vertically up, the beam cannot be moved vertically up, beam cannot be taken out from the wall, or beam cannot be rotated against the wall. So that we will say that beam and wall connection is fixed type of support. And similarly, there are also, when 2 beams are together, then you can say that they are connected by internal hinges. Now these things will become more clearer as we go for further videos of the problem, but at the moment it is sufficient to know that there are 4 types of supports and these are the properties. So anytime you see these symbols in the problem, you have to replace them by appropriate reactions and go ahead. This will become very clear as soon as you see the next videos in the series. Thank you.